Good afternoon, class. My name is Dr. Rex Kirk, and I'm your professor in this class, and I've also posted a video of John introducing you. And today we're at the Canadian Feed Research Centre in North Battleford, which is our large feed mill research facility on feed processing. And normally we bring you to a feed mill for tours so you can get to know the place. We'd also bring you out here and do hands-on videos, but unfortunately with COVID, that is out. So I've got special permission to come and take videos of the various facilities, and today I'm going to focus on a tour to give you an idea of what's involved in a feed mill. In class, we're going to cover each of the different aspects of the process, and I've got some of those pieces around me. So it's okay if you're a little confused in this video, but I just want to give you a bit of a tour of what a feed mill looks like, describe a little bit of the process, just so you have a sense of what's going on for this lab. Behind the camera is Jessica Wang. She's our feed industry liaison and works with commercial clients, so I've recruited her to be our videographer. So thank you very much, Jessica. In the CFRC, we have an operating feed mill. It's a 20-ton-an-hour feed mill, and we will do some videoing over there as well. But it'll be a little noisy because the client is, we have an industrial client that rents the place, and so they'll be making diets, so the sound might not be perfect. So we decided to record some sessions here in the pilot line, which is essentially a small feed mill. The commercial one does 20 ton an hour. This one we probably do about 2 ton an hour. So to give you a bit of a sense. To introduce the topic a little bit, so you're going to be taking feed technology. And we need to be able to create feeds for our animals. I know when you went into animal science, you might not have been thinking about, how do we feed them or how do we produce those feeds, but it's a very important part of the industry. 70% of the cost of our production cost is typically associated with feed. And so we need to be able to do that as efficiently and as effectively as possible. So in this class, we're going to cover all those aspects. And this is the plant, these type of plants is where we produce those diets. And so understanding each of those processes that go into it is important for you. The feed mill is about 6 stories high, and there's various processes through it. So on any given floor, you could have a number of processes because we take product up, it goes through a process, goes down, goes up through another conveyance and down. And so just on this floor here, a couple things to show you as well. We talked about conveyance. here's the leg, right? This takes conveys the product up and down, or conveys it up, and we have another one right beside it which drops it down. And so we're able to move product around the plant, and so we use gravity as much as we can. There's one thing that's true of all feed mills. There's one thing that always works for us, and that's called gravity. Everything else can break down, gravity seldom breaks down. And so in this plant, things I want to show you is we talk about the conveyance system. So in this case, actually this conveyor is actually used to take product that has already been ground and mixed. So I'll show you a little later in the slides as we go along. But during this video, we will be switching between the various sizes of the plant. As I mentioned, we have 3 scales in this plant. We have a lab scale, which is smaller, standalone equipment, so I'll be able to show you some of the small equipment open. But we'll also then pan into the larger scale, which is the pilot scale, which is 2 ton an hour. So for example, we'll show you the small pellet mill, the pellet mill in the pilot line, which is 2 ton an hour, and then we'll show a clip of the 20 ton an hour plant. And so as you go through these videos, there's going to be a little clip of each where I can, just to give you a sense of some of the different scale, as well as the, to try to use each of them to teach you a little bit about the equipment. So there will be a lot of switching between plants as you go through this video. Here's Jessica holding the camera for me, so I snapped a quick picture of her so you could meet her. Hi class, so this is Scott Bischoff, and he's our plant operator, right? So he runs this place, and there are so many moving parts, I have no idea how he does it. But I wanted to introduce you to Scott, and I really wish you could have come out for the tours, because Scott spends time with you guys and walks you through all kinds of stuff and entertains you with stories of things working or not working. Usually the not working part is the more interesting part.
It's all related.
It's all related. So anyway, this is,
Yep.
what was I saying in the class?
Best of luck to you.
Thanks, Scott.
You bet.
So, the operator's job is many, and he's Scott is usually around the plant repairing, running, problem solving, all that good stuff. He just turned off the pellet mill, so there we got it a little more quiet now. But this is our operating room. And in this room we've got basically the computers that run the whole system. So Jessica, if you could just sort of scan over there a little bit. We have various panels, and we'll talk about this in class, and John will do a demonstration for you running the plant. But essentially, we put everything in the computer and let the computer control it for us. So this is the batching screen. Like I say, John will talk a lot more about it, but essentially what we've got here is a number of bins. So this is showing our pneumatic scale where we take the ingredients up. We've got our microsystem where different smaller ingredients are weighed up. We've got our larger bins where we share bins with the industrial clients, say bring over wheat, barley, and things that are larger. And this basically shows a diagram. So in the computer you would set up and say, I want this many kilos of this, and this many kilos of this, and this is the process. This would just follow it. And there's a way for us to monitor that. So there's a whole bunch of different little screens we can pick. I'm not going to mess with it because the system's actually running right now. But basically we have different panels, so we can see right now that they've got product going over here, and so that conveyor is running, and it's going into that bin there, which is LB08. So it shows the hammer mill and roller mills and all the various pieces of equipment. So within the plant, of course, scales are very important. We're going to have a whole lecture on scales and the importance of scales because we need to weigh everything, and it needs to be weighed accurately. We have different sizes of things we have to weigh. You don't use a scale and weigh a gram of something that you normally weigh 3 tons on, right? So we have a series of scales. So here we've got on the digital system the micro scale, which means small quantities. I think the minimum you can do on it is about 20 grams. Then we got the larger scale, which goes up to half a ton. And then we have liquid scale as well. And then we have our major scale, which we're scaling big ingredients. It's all run by the computer, but I'm just saying we have a visual here of the readout from that. So one other piece of equipment that's unique to this plant, and very unique in the world really, is we'll talk later on this class about near-infrared spectrometry. It's a way to measure the chemical quality of something real time without any chemical analysis. So it's basically using light to analyze the chemical consistency. And this machine does that as the product flows through. So we have various locations in the plant where we want to monitor protein, moisture, fat, that kind of thing. And that's what this machine does. It was built by Bueller. We also have another unit by Rupert. And but in this system, we put alarms on it. So when Jessica's making diets, and say she makes a mistake and puts in the wrong amount of soybean, you never do that, Jessica, I know. But say a mistake is made, or the system's not working, there's been an error, the screw doesn't turn on or something, or there's a malfunction of the scale, this will tell us that's not the protein level you set for that diet, and it'll give us an alarm, and then alert the operator, so we don't send that out to the animals, or we basically have a notification we need to fix something right away. So we're in the industrial side in the operating room where Dallin here is keeping an eye over the production of whatever they're producing right now. I don't know what it is. Good, I don't know, I guess, because they're a business. They make their own products. And so he's monitoring the computer system, which we talked about on our side. And he's also got cameras in various places to keep an eye on the various processes and equipment and just make sure everything is working the way it should be. Okay. Pretty much sums it up.
Yeah. Basically, the process is we schedule formulas, we run them through the grinder. We have 2 grinders here, go into this bin where they're all ground up and mixed pretty good. And we've got microscale for small ingredients and ads, which is like medications. Drops into the mixer, this is where we add things like tallow, grease, and into the pellet bins. And we got a pellet system. Cooler. Right now we're making a bundle. We got that set. We got our converters.
So in our plant we have what we call mimic boards. These boards where we can control the plant from anywhere in here. So because we have one operator and he's got to be all over the place, it's impossible for him to run from the second floor to the sixth floor to fix something and then back down and monitor in the control room. So you probably noticed as we're walking around, there's more of these mimic boards around where we can control the various parts of the plant using these systems. Okay, so what we've got here is our receiving area. And so we're up above the trucks where the trucks would come in. Down below us, there's a truck would drive in. There's a pit there with a scale where the truck sits on it. And the material is dropped into that pit. And they measure the weight of the truck before and after loading. And then that's conveyed over to our grain bins, either outside or the bins above the scale. No, we're not in the tropics or the jungle. That's an electronic thing to try to chase away the pigeons. We have pigeon problems here, so that should scare them away. So, what I want to show you here is the bins. You guys have probably all seen grain bins. These are very large bins that we hold the larger quantity of ingredients such as wheat and barley at our mill. So here are the oil bins. They contain tallow, as you can see there, and there's another one for canola oil. So our plant is a bit unusual in that in a research facility we have a lot of different ingredients, and so this system here is basically our version of a receiving area where we have many different ingredients. We go up in 1 ton totes and it goes down to a scale. Unfortunately, the scale is hidden here right now, but there's a scale below. Materials conveyed out and weighed. So say we need 100 kilos of wheat and we need 20 kilos of soybean and we need 5 kilos of dical and those kind of things. Those will all get weighed out in that central scale and then blown to the mixer to be mixed. So an essential part of a feed mill, of course, is storage. We have a lot of ingredients that we have to use, and so we're in the warehouse of our center, and so there's all kinds of ingredients that come in a little smaller quantities, vitamins, minerals, enzymes, those kinds of things, and so this is just a warehouse where we would store those and warehouse them. So in our mill, we use a lot of byproducts, things where they've been processed to take ingredients out for humans. In this case here, it was to take out omega-3 oil, it's camelina meal. And this is a high protein meal. We'll talk in class about byproducts and meals, but that's a meal that Kiana, one of my graduate students, and she'll be making a video for you on the production of this, where we extracted the oil from the seed to make a high protein meal, and it's also going to be used as a source of omega-3 fatty acids for laying hen trough. So there's durum wheat, and so wheat is being added to a diet because chickens do well with a little bit of whole wheat in the diet. So I believe that's what's probably happening in this process. They've made pellets, so they're adding some wheat to it. But anyway, that's what wheat looks like. So one of the things we have to talk about whenever in our class is conveying and storing materials, and whenever we move something through a conveyor, whenever we're handling it, we have to think about how dense it is. You know, if you're moving rocks versus flour, they're very different things, right? And I thought I'd just point that out. Here's a 1 ton tote bag, but normally a 1 ton tote bag is much larger, but it's filled with calcium, limestone, okay? And so there's 1 ton of limestone, this little tiny bag. Now, if we zoom over here, just follow me for a second, Jessica, I don't know if that'll work. Maybe, am I too close? Here, let's do one of these here. So, here is a 1 ton tote bag of faba beans. The label on the other side of the bag. So these are full of beans. So that's how much space a ton of beans take. And you've seen how much the calcium takes. So, and if we were to do something, a light fluffy thing like oat hulls or something like that, it'd be twice as big. So you get a sense, things have different densities. So what I want to show you now is the scale. So we have above us many bins, horizontal bins plus there's bins outside. Those bins are all connected by these large screws. They have a large screw rotor in them. And then whenever the computer calls for an ingredient, it will turn the screw on for the right bin obviously, and it will feed it to that scale. There's a scale down there, a big hopper that holds 3 tons. and it'll weigh one ingredient at a time until it hits that weight, and then it'll go to the next ingredient, and you see there's many pipes that go into that. Okay, so another part of feed milling operations is obviously safety. We have to apply by, we'll talk later on in class about HACCP and Feed Assure and the systems we have in place to ensure that there's no cross-contamination of products, of species. And so these are locked cabinets in which we keep our medications. I don't even know where the key is. Nobody trusts me with the key. It's probably a good thing. So we keep our medicines in there. So say we need to add an antibiotic to treat an animal with a disease, and by putting it in the diet, we have that. And anytime we use them, we have to weigh each day the product to make sure we've actually used the amount that we're supposed to. And if we do use any animal byproducts, for example, meat and bone meal, that's kept under lock and key too, because there's many restrictions on that as well. So we do have locked cabinets for that material. So we're in the hand add section, and so a lot of our feed manufacturing is fairly automated. You have a computer that tells it to weigh a certain amount of things, it turns on augers and feeds it to the mixer. But there's also ingredients that we need to add by hand. So for example, if we look over here, maybe turn over there a little bit, we have, here's choline chloride. So this choline is something we would add to poultry diets. There's amino acids, we've got valine is there, we've got glycine is there, tryptophan. So there's a bunch of different ingredients that we would use, but not in large enough quantities that we're going to automate it. So in that case, we have something called hand add. So when we set up the computer to make a diet, it's going to call for ingredients. So what we're going to do is we're going to come here, we'll scan the bucket, and okay, and right now the computer's not on. Oh, I guess it is. So now it wants me to select a diet to make, and so what it'll do is it'll keep track of, in this bucket are the ingredients, and it's going to tell me add 1 kilo of choline. So we'll put it on there, we'll weigh our kilo, and then it'll tell me, okay, add 3 kilos of dical. So you take that, weigh that, and in the end you have a bucket like this that has a barcode on it that we'll put into the mixer when it calls for it upstairs. So that's what we call hand adds. We try to do as little O as possible, but it's quite critical. And so we just have 2 different scales. Please don't look at my weight because that is really quite embarrassing. But this is a scale to weigh for the larger ingredients, and we also have a small scale here to weigh the tiny quantities. So below I showed you where we add the hand add, where we weigh up the pail. We go to make the diet, and it's in process. It's going to come up with this computer and tell me it's time to add that hand add. We use a little magic wand, scan the pail, make sure it's the right pail, and then we dump it into a quart in the floor. I'll adjust so you can see it. Here, we'll dump that in, and that goes straight into the mixer. So this is the premix hand weigh area and the industrial line, so the line that is 20 pounds an hour. So just like our smaller line, they have a hand control system where they weighed up pails of cereal. So these ones are already empty in there. They have a little barcode to make sure you're matching up the material weighed up going into the right diet. And when the computer calls for it, it's dumped into the mixer to feed this system here. This is our micro scale, so whenever we want to measure small quantities, I showed you the large one, or I guess I will show you in the video, the larger unit. This is a small micro scale unit on our pilot line, and so it has sort of those main ingredients we use all the time that are only added in small quantities: salt, limestone, vitamin, mineral premix, say, some of those kind of things. And so they're very accurate little scales, little screws that go onto a scale, and it measures it down to the gram before it gets dumped into the scale, or to the mixer, which is just below you. So this is the industrial line, and what we got in front of us are micro bins. They're small bins that are automated to measure smaller quantities of material, such as vitamins and minerals, that kind of thing. At the far back, you can see below is a scale, and those green pipes going into it are all the pipes from the various bins, which will dump into that scale. And they have augers that are on hydraulics that feed the material in until the scale hits the appropriate weight. So one of the things we have to talk about whenever in our class is conveying and storing materials, and whenever we move something through a conveyor, whenever we're handling it, we have to think about how dense it is. you know, if you're moving rocks versus flour, they're very different things, right? And I thought I'd just point that out. Here's a 1-ton tote bag, but normally a 1-ton tote bag is much larger, but it's filled with calcium, limestone, okay? And so there's 1 ton of limestone, this little tiny bag. Now, if we zoom over here, just follow me for a second, Jessica, I don't know if that'll work. Maybe, am I too close? Here, let's do one of these here. So, here is a 1-ton tote bag of faba beans. There's the label on the other side of the bag. So these are full of beans. So that's how much space a ton of beans take. And you've seen how much the calcium takes. So, and if we were to do something, a light fluffy thing like oat hulls or something like that, it'd be twice as big. So you get a sense, things have different density. So what I want to do now is show you a hammer mill. The majority of our products that we feed to animals need to be ground down. There's multiple reasons for that, and we'll talk about that in class. But I have a small hammer mill here open. We'll see some bigger ones in the rest of the tour. But the hammer mill is essentially a set of rotating hammers. These are rotating at very high speed, about 1800 RPM in this case. And they're encased by a cage, a screen that has holes. These holes are very large. Normally our screens are much smaller. I just can't find a smaller one right now. And what happens is the grain comes in, hits those hammers hit it, they make it explode. They break it down. And from there, if the particles are small enough to go through the screen, they do. And they go out and we collect them for making our feed. Okay? If they're too small, or too large I mean, or they hit the edge, they bounce back, hit the hammer again, and they get small. Okay? So hammer mills we use to grind a lot of stuff. Like say this is a very, very coarse screen. Most of our screens are about 3 millimeters, so that's about 3/16 of an inch. This is much, much bigger than that. So this would be like coarse grinding of fiber or something like that. Whereas most grains we would grind a little finer than that. And so normally, obviously, the door is closed and this thing is running its high speed, but we have it open for you. The other thing that's worth mentioning in here is it's really a bad thing if you get any metal in there, somebody drops something in there. And so we also have a magnet. So if product is flowing through here and going into there, it goes past the magnet. So you don't, oh, I probably just ruined my car starter. Anyway, you have a magnet to catch any pieces of metal that, you know, come off the plant or whatever. So that's an essential part of the hammer mill. So this slightly larger hammer mill, I showed you the lab mill. This is our pilot line mill. I think it normally do a 1/2 ton or 5 tons an hour. And we're going to all closed up, of course, the hammer inside there. This is the screen that goes around the outside. So I don't know if you can see that in there or not. Maybe I'll put it out against the light or something. You see the hole. So that's the screen that the material has to be ground through in order to carry on to the rest of the plant. And this is the hammer mills in the industrial side. I believe they're about 350 horsepower each. And we have a pair of them. This is a post-grind plant, so we have very large capacity hammer mills. So here we have a very small roller mill, but it allows me to show you the inside of a roller mill. So probably a little hard to see. I'm trying to use my camera as a bit of a light, but there's essentially 2 rolls that are corrugated. If you can hear that when I'm rubbing with my fingers. But there's basically corrugated rolls. The grain will fall between these 2 rolls. The rolls are counter-rotating, meaning they turn into each other. And they basically grind the grain between the rolls. And so this is one mechanism of grinding which we'll talk about in class, called a roller mill. So we also have in our plant a roller mill. So in class we'll talk about 2 types of grinding systems, a roller mill and a hammer mill. One's got advantages over the other for sure. We use both, but we primarily use the hammer mill. The roller mill we use for certain applications. And it's a pair of rolls, and I showed you the small rolls. Well, this is a larger unit, and it's actually got 4 sets, one above the other. So you grind a little bit, goes to the next, grinds a little closer, and eventually by the time you get to the bottom, the rolls are very close together and will grind the material. So this is a 4-roll stand. Most are usually only 2, but we have the ability to go up to 4 passes in a single run. Okay. So here's a mixer. And this is what we use for making dough or, I don't know, whatever. I'm not really a very good cook. But we can use this for small quantities in a research mill where we might be making up some pre-mix or something like that. But it gives you, the idea is that you need to take all your ingredients and mix them into a homogeneous mix, meaning they're equal all the way through. Well, in truth be told, this is fine for small quantities. We need to do much larger. So I'll show you mixers in the rest of this video that are larger, but let's take a look at the inside of a mixer, which is a bit smaller. So maybe I'll get you to point, Jessica. So here's the inside of a mixer. This has got both paddles and ribbons, and Jessica's going to try to point with the stick there. Oh, you want me to point with the stick? Okay. Well, we'll see how coordinated I am here. So there's a paddle, which mixes product around. This thing is spinning. There's two systems here, and then there's ribbons. And so both of them are turning and allow you to mix the product back and forth, top to bottom, and kneading it as well, so throughout the system, and then from the mixing process it goes down. So this is the inside of a combined mixer. The mixers we have in the rest of the plant are just paddle or ribbon, but this one's got both. Mixer. And so in this mixer we have two paddles that basically take the product that we've formulated and weighed and put in there, mixed it so we have a homogeneous mix, and then it's conveyed, goes up, and upstairs we'll talk about it, but it goes up to the pelleting line. So it'll put it over the pelleter in a system. So what we have here is the mixer. It's a 3-ton mixer, it holds 3 tons of material and mixes it up. And then it's got a surge bin below it to take it out to get conveyed up to the pellet mill. So this is our conditioner, so it's an industrial line, and what it does is it takes the mass product of this mixer material, adds steam to it, so we get moist and hot before it goes to the pellet mill. Again, this is 27 hours capacity. So this is a very small pellet mill in our lab, and what it's got is a die that rotates, and there's little holes, I don't know if you can see that from here, Jessica, maybe not. But there's holes in the die, and inside are 2 rolls that are pushed against the outside of that die. And so what happens is the product goes through a feeding system, through a conditioner, which is this pipe that has steam injected into it. It gets hot and moist, and then from there, with this closed, the product falls down here into the middle of that die. So you go into here, and then as this die turns, and the product's going to get squished between the roll and the die, and it forced over these holes. And then there's, inside of this machine, there's a knife that you can set down close to the die if you want to make it small. Okay, so that's the inside of a small pellet mill. So class, this is a pellet mill, a relatively small one, but it seems to work pretty well, or at least Scott has it working well. And we'll talk a lot more about this in detail in the future, but this is basically a die. It's a metal ring with holes through it, specially shaped holes. We'll talk about that too. And there's basically 2 rolls that are on bearings right here, and they're pushed against the die. Feed goes through, maybe you can just pan over here, sorry. Feed is going to come out of the conditioner retentioner. It's going to come out through a little spout and into the middle of the die. And with this die rotating, the stuff's going to get caught between the rollers and pushed out through these little dies and form pellets. Oops, you can't see that, but you'll see when they come out. And then what Scott just adjusted a second ago was to back off the knife. There's a knife that goes against here so we can set really short pellets or longer ones. The longer ones will basically break off as they're coming out. And then it goes down to the dryer cooler. So Scott has agreed to run a little bit for us as part of the tour, and I appreciate him doing that, so we'll let him do his thing. So Scott has an operating panel there, so we have panels throughout this building, and we'll talk about those. And so this one here runs the pellet mill, so Scott is moving product over and putting it up to the conditioner. Maybe. So at this point, Scott is getting things turned on and getting stuff moved around. And now he's waiting for it to do its thing. The conditioner, so the product is coming across the top. It's going to go into conditioner where steam will get put in. We'll talk about that. The retentioner, which will hold much bigger. And so doing 20 ton an hour of pellets that they're crumbling right now. That product is pelleted. It's going to need to be cooled. So what we have sort of hidden up there, and I don't know if you can see it up there, Jessica, or not. Might be difficult. But we have a dryer cooler up above. I can show you other ones when we go through the plant. So these pellets are hot and moist. We need to cool them off so they don't mold. And so that's our cooler. Below the cooler is a crumbler. And the crumbler is, so up there is the dryer. And so the pellets are coming out hot, and we need to be able to cool them and dry them. And so that just basically blows air through the material and cools it. After the pellets are cooled, depending on what you're feeding, but if it's a small animal like a chick, we'll break those pellets up into smaller pieces. That's called crumbling. So right below this pelleter is a crumbler, which is basically a set of rolls set quite distant apart to break that up. If we're not crumbling it, just goes flow straight through it. Other things to show you in here while we're on this. So this is a cooler, dryer, crumbler. So the pellet's going hot. On the kid up there has got cold air blowing through it, or air going through the cool pellets. And the air is going down to that great machine which is crumbling, which is breaking the seeds up. So this is our steam flaker, and this is where we would take grain, heat it up, and then turn it into a thin flake. So basically breaking some of the surface area so that cattle can digest it without creating fines. That's the primary use. And so what we have above us is a steam chest. It's a chest where steam is inputted into the material. It allows it to soften that seed, whether it be oats or barley, whatever, or corn. And then what happens is that after it's been in there for a period of time, maybe 5 minutes, something like that, whatever our target is, then we'll put it through the steam rollers. So the steam rollers, unlike a grinder, the rolls are going the same speed. In a grinder, one roll is going twice as fast as the other, so it basically rips it, shreds it as it goes through. The other is the grinder has corrugations on it that are quite severe. This one might just have minor corrugations on one side just to break the cell wall a little bit. But basically they go through at the same speed. Their job is to squish, so they're going slower, and they're bigger, heavier rolls, so the angle isn't quite so sharp on them, and it basically flattens the seed. You get the steam flattened seed. So you get material with no vines. It's easier for us to feed to animals. And then from there it goes down to the dryer cooler. So this is our dryer cooler. I just opened the door, so hopefully you can see a little bit. It's probably too dark. But essentially this is from our flaker. So above we're going to flake seed, where the hot rolled material needs to be dried. And so this is a counterflow air cooler. So through the floor is air blowing up, and the grain will fall through the floor. And there's a sliding floor, so what happens is whenever the air going out is cool enough, it's cooled down and the grain enough, the floor opens, some of the grain falls out, and some new grain comes on the top, new in this case, flaked material. The same kind of dryers, smaller, are used for our pellet mills. And this here just also just distributes the product along so that we get a flat top on it. So this is a twin screw extruder. Well, again, we'll talk more about these in class later on, but this is what we use to make pet foods, aquaculture feeds, those kind of things. And it's essentially a cooking screw. So we take material, we add steam to it like you would in pelleting, except for whenever we put it through the extruder, we go to very high temperatures. There's two kneading screws that basically force material along while we cook it. And so you can see the ends of the screws here. And whenever the product comes out, it goes through a die. Here we go. So here's a die. So the product is forced through those screws through these tiny little holes and out. And so then what happens is when it comes out, it expands because it's so hot. The steam is boiling off and it expands out. So if you look at a dog food or something like that, kibble, you'll notice it's all expanded full of air holes. That's because that steam was expanding when it came out of the system. If you didn't have a knife on here, it'd just be a mile long. So instead what we have here is the die is pushed up against that knife, and that knife is rotating at high speed, and it's cutting those things off as they're coming out, so you get your short kibble. The faster it goes, the shorter the kibble. So one of the processes we do at the plant is extrusion, and upstairs I'll show you the extrusion system here in a minute. But an extruded product like a pet food or something like that will come out very hot and moist, and so we need to cool that. And this is actually a cooler. It's called a fluidized bed dryer. A fluidized bed dryer basically bounces material around, blows air around it, and so this big long unit vibrates and has air blowing through it to cool a product. And this is right directly below our extruder. So we'll talk about that as well. Another thing that's important in a mill. So in our class we'll also talk about vacuum coating, and it's a process whereby we can add fat or other ingredients to a pellet. You'll find in class that we can't make a pellet with high fat because it's a small part. And so what we do is we add it after the fact. So this is a small vacuum coater, and we'll talk about it in more detail. But basically, you put your products in there, pellets, extruded material, and put the fat in there with it, pull the vacuum, and then release the vacuum. So the pressure, basically, the change in pressure drives the fat into the pellets. So this is a large vacuum coater, and it's basically doing what the other machine does, but except for half-ton batches. It's used extensively in the aquaculture industry to add more fat to pellets, but it's also being used in other parts of the industry as well, where we need to add material to the outside of that pellet. Here in the class we'll also talk about specialty processing, and one of those is using a technology that we've been working on at the university in our program, where we can clean out grain that's got toxins in it. So there's a disease called fusarium that causes vomitoxin, deoxynivalenol. And so what we want to do is take those infected kernels out from big batches, and that's what this machine does here. It's essentially a near-infrared transmittance sorter, NIRS sorter. But what it does, instead of looking at just a batch like we did in the lab, where you just get an analysis, but instead what it does, it looks at every individual seed and then decides if that seed should be kept or should go into the bad pile. And so there's large drums in there they're rotating, and the grain gets caught in those drums. And then there's light that shines through the seed and so on. We'll get more into it in class, but this is a bone mill which does 3 tons an hour. And so we've been using it for sorting fusarium. Whenever we make our product, of course, we need to get it to the customer in the form they want. Lots of our product goes in bulk, so we'll have the outdoor loading facilities, and I'll show you those. But one of the things we can do is bag it. And in our plant, it's rather manual, so we can take the empty bags, mount it up on the, apparently I'm not the expert on this, mount the bags up, and then pull the lever, and through scales it will weigh that out for 20 kilos or 25 kilos, whatever it's set up for now, I think 25 kilos. And then we use a machine to sew them. So that's how the bag can come out of here. Another way it can go out is in a tote bag. In our case at the CFRC, we send them out in plastic totes. So maybe, Jessica, if you could just come around. So this is our shipping area. So above us we have bins where the final product has been stored. And when the truck comes in, and the truck will have many bins in it to haul different diets, the product will get dropped out of one of the bins into this hopper here. The hopper goes over the truck where it needs to drop it and drops it in. And there's a scale on it to measure what weight we put in the truck. And we also have a sampling port, so they take a sample. So it's important to take a sample of everything you ship out, so that if there's any issues you can measure it and just make sure you understand what the problem might have been. We don't do a lot of analysis of the feed mill, but there's a couple things that we do need to measure. One of them is particle size. For grinding material, we need to know what size that material is. It varies, even with the same screen, the same speed of hammers, you can get different sizes. For example, soft wheat gives you a finer size than a hard wheat. Fibrous materials give you a larger size than a non-fibrous material. So we have a system to do that. And basically it's a series of sieves. So a sieve is a little plate with a hole in it. There's a machine, a disc I guess, with a set of holes. And they go from very coarse down to very fine. So the bottom one here, you can't, it's just like, you know, a hair wouldn't even fit through it. And so you have a series of sifters, screens. And so what you do is you put 100 grams in the top of here, and go to the lid. Put it inside here, pull it back, take it back. I know that's the power going right now, we use a plug. And then it shakes and beats it, and it does that for I think 10 minutes, I can't remember. Then what you do is you take and you measure each of those different sieves. And so by looking at the relative weight of the largest, and the next one, the next one, the next one, you put it into a calculation, it'll give you an average particle size, say 700 microns, and then you'll get a distribution through a standard deviation, 3 or 4 or something like that. And then you'll also be able to look at a graph and say how many fines do I have versus coarse material. So that's an important part of analytical work at a So this here is a pellet durability tester. It's called a Holman tester. So we're going to have it upside down backwards. And what we do in here is we want to determine how well those pellets will stand up during transport. And so what we do is we put pellets in here that we made. So let's clean that out. Sorry. We're going to put 100 grams of pellets in here. Close this up. Close the lid. Lock it down. And you turn on a fan, and it runs for 30 seconds. I can't remember Jessica. Anyway, this fan beats those pellets around, and the fines fall through the screen, and only the pellets are remaining. So when you're done, you take it like this, and open that up, and then dump the pellets into a container, and you weigh those pellets. So say you start with 100 grams, and at the end you have 70 grams left over after it's been all beat out. That means you've got a 70% PDR, or 70% pellet durability index. And so we typically want to be more up in the 80s and 90s. And so that could be an indication we have to do something different in our pelleting process. Another analytical tool we use in the feed mill is, in some places, an NIRS, a near infrared spectrometer. You can have a whole class on that. But here's our unit, and it's not turned on right now, I just didn't warm it up. But basically what we do is we can take a sample of our wheat, or our feed, our grain, whatever, put it in this little cup, put the cup in here, turn this on, push a button, and it shines light up on it, measures the light that's returned, and using that information, it can give you a protein content, a moisture content, within about 30 seconds, and I don't even destroy the product. I don't send it off to the lab and give it to Jessica. Well, Jessica would like you to do the analysis, but we can do that very quickly. And so this is a very useful tool, and Mary Lou Swift will come and talk to you about that issue. This is our little lab area that we do experiments with feed processing. And this unit here is a briquette maker. So we've talked about pellets, and they're, anywhere from the size of your little baby finger up to, the size of your thumb, I suppose. This one produces a pellet that's about 50 millimeters in diameter. It's called a briquette. So it's designed for processing straw, for example, into a pellet product you burn called a briquette. We use them for feeding studies, for feeding cattle in pasture, for feeding sows, when they're gestating, those kind of things. And it's essentially your ground up material is pushed by a hydraulic cylinder out a guy that we can adjust the pressure on and create this very high pressure system called these pellets. So there's an example of a briquette that we were making for a client yesterday. So hopefully they'll be marketing these kind of products on the market soon. But it's basically a very large piece of material for feeding critters. One of the things we're going to talk about in our class is specialty processing. And one of the things that I've been researching is how do we explode fiber? How do we change it so the nutrients are available, so the structure of that fiber is different? This is a unit we use to do that. So basically I have a steam generator, something to generate very high pressure steam. And behind me is a vessel, which I'm allowed to pump up material to very high pressure, hold it for a minute, and then pull the button and it explodes. So we'll go into more detail in class, but just from a tour perspective, this is a system we use called steam explosion. And we're trying to incorporate it to the feed industry. It's used pretty extensively to make fiberboard, modify wood, and things like that. Well, I hope you enjoyed the tour of the feed mill. Sort of disjointed. When you walk through, it's even more disjointed because you see 4 different processes in mid-stage at each floor. But I did my best to take a bunch of clips and stick them together and hopefully give you a bit of a sense of some of the things you're going to see. You'll learn a lot more about them. This was just an introduction. It took me a little longer than I'd hoped to do some of this work. I guess everything does in the first time we do it. So anyway, I hope you enjoyed the video, and we'll talk to you in class tomorrow. Thank you.